Question number 18. The sketch below represents the curve y is equal to x squared plus 3 and a straight line RS, which meets the x-axis and the y-axis at the point 5, 0 and 0, 5 respectively. The line intersects the curve at point R and S as shown below. Part A of the question. Find the equation of the line in the form of y is equal to mx plus c. Solution. So this is the point where our line RS meets y-axis at point 0, 5, and this is the point where our line RS meets the x-axis at point 5 and 0. So we first find the gradient, which is m is given by y2 minus y1 over x2 minus x1. So this gradient of ours will be given by 5 minus 0 over 0 minus 5, which is 5 over negative 5, and our gradient is negative 1. Our y-intercept at point 0, 5 is 5. Therefore, we are going to say y is equal to mx plus c. So our gradient is negative 1, so we are going to say y is equal to negative x plus the y-intercept, which is 5. Part B is asking, determine the coordinates of R and S. Solution. Now, the equation of our curve is y is equal to x squared plus 3, and the equation of the line RS is y is equal to negative x plus 5. Now we equate the two. We say y is equal to negative x plus 5 is equal to y is equal to x squared plus 3. Therefore, simply negative x plus 5 is equal to x squared plus 3. So this one can simply be represented as x squared plus x plus 3 minus 5 is equal to 0. So x squared plus x minus 2 is equal to 0. This is a quadratic equation. So we factorize. We find two factors whose sum is 1 and whose product is negative 2. The two factors are negative 1 and positive 2. So we are going to say x squared minus x plus 2x minus 2 is equal to 0. We factor out x, we say x into bracket x minus 1, then plus, we take the constant, we say 2 into bracket x minus 1 is equal to 0. We take our x and our positive 2 here into one bracket, we say x plus 2, and one of the brackets, which is x minus 1, is equal to 0. So either of them is equal to 0, so x plus 2 is equal to 0. Therefore, x is equal to negative 2. Again, x minus 1 is equal to 0. Therefore, x is equal to positive 1. Now, taking y is equal to negative x plus 5, we can find the value of y here. We say y is equal to negative, then negative 2 plus 5. So y is equal to 7. Now, we are going to say our point R is having the coordinates of negative 2, 7. Again, we take y is equal to negative x plus 5. Therefore, y is equal to negative 1 plus 5. So y is equal to 4. Now, the coordinates of S are therefore positive 1, 4. And we are through. So part C of the question is asking you calculate the area of the shaded. So part C of the question is asking you to calculate the area of the shaded region. Solution. So in part B of the question, we equated the equation of the curve and the equation of the line RS, and we found that x is equal to negative 2 and x is positive 1. Therefore, we are going to use the formula. Area is the integration of using the values of negative 2 and 1, and then we integrate the line minus curve dx. So area is equal to the boundaries. So area is equal to the line, which is negative x plus 5 minus x squared plus 3 dx. So area is equal to 1, negative 2. So negative x squared minus x plus 2 dx. Now, when we integrate, we are going to get area is equal to x cubed over 3 minus x squared over 2 plus 2x, 1, negative 2. So at x is equal to 1, we are going to get area is equal to negative 1 over 3 minus 1 over 2 plus 2. This one is 7 over 6. So at x is equal to negative 2, we are going to say area is equal to negative 2 cubed over 3 minus negative 2 squared over 2 plus 2 into bracket negative 2. This one is minus 10 over 3. So total area will therefore be 7 over 6 minus negative 10 over 3. So our area is 7 over 6 plus 10 over 3. So this one will give you 27 over 6. And therefore this one will give us 4.5 square units as the area.